So you might remember we were talking about evolution, and what I'd been talking about when we were interrupted, man, I guess that was a week ago, was types of selection. Selection is the mechanism that drives evolutionary change. Evolution is only change through time. Selection is what we think is the primary mechanism that causes evolution to happen. It's not the only one. There are other things that can cause, hereditary change in living species over lengths of time, but it's thought to be the primary mechanism that causes it, the motor that drives that change. And we've talked about the distinction between artificial selection and natural selection. They both start with the fact that individuals in a population vary. They're different from each other. Everybody in this class, we're all different from each other in thousands of ways. Some very obvious, like hair texture and skin color. Some very subtle, like, differences in susceptibility to certain diseases or cancers. But we're all different. That's true for populations of any species. You could go outside now, and if you could find a place where the snow has melted, you could study the blades of grass, and you'd find differences if you looked closely enough and learned what to look for. You could go out to the nature reserve and find differences in, in the trees. Every sweet gum and every willow oak is different from the others of that species. Some of that variation is passed on from one generation to the next. You inherited your differences from your parents, and if you have children, you will pass them on to them. Artificial selection starts by saying individuals vary and people select the individuals that vary in desirable ways, encourage those to breed, discourage the ones that don't have traits that they like from breeding. Repeat that over many generations, and you can get a domesticated species of animal or plant to change a great deal. And we've seen some terrific examples of that. Everything from a dinky little Mexican grass turned into great big ears of corn to tiny little red berries that make your mouth burn turned into big, beautiful peppers. And there's lots more examples you could pick. Dogs and cats and sheep and cattle and tomatoes and goldfish and every species that we've domesticated, humans have changed mostly by applying artificial selection. And by the way, people have known how to do this for thousands of years. It began as soon as different groups of humans developed agriculture and livestock breeding. Even before people knew what it was called, even before people wrote it down, they understood the principle. Natural selection, Darwin said, works like artificial selection, except there's no conscious choice involved. There aren't any breeders. Instead, individuals vary. Some vary in ways that give them a better chance of leaving offspring in the environment where they live. Others, of course, will vary in ways that give them worse odds of reproducing. Some bunny rabbits in a forest will just happen to be a little bit faster and able to get away from predators. Some will be a little bit better colored and able to blend in and escape predators. Some may just reproduce faster and have so many kids that the predators can't make a dent in them. It depends. But the individuals that vary in ways that give them better odds leave more offspring like themselves, individuals that don't leave fewer offspring like themselves repeat over many generations, and you end up with change. And then we talked about a third type, sexual selection, where human breeders aren't doing the selecting, nature isn't doing the selecting. What happens is that members of one sex pick out mates that have certain traits and not mates that have others. Female birds might pick males with brighter feathers or louder songs. It can actually work either way. Either sex can select traits in the other. And those that have traits that are preferred by the opposite sex have a better chance of reproducing. So that would be sexual selection. Can we actually get new species? Everything I'm going to talk about from here on out is a case study of how this happens, how we can know that this is enough to give us new species. And it's based on a place that I have visited frequently. I haven't been there in a while, but this is something that anybody could go see for yourself over spring break with a car and enough gas money to get to Las Vegas and back. This is something, it's not quite in your backyard, but you don't have to travel to the Galapagos Islands like Darwin in order to see this. When I teach case studies like this, I'm not going to expect you to know the details of the case study. You don't have to memorize the name of the species that I'm going to talk about. You don't have to memorize the place where they're from. You don't have to know anything about that. When I teach with a case study, what I want you to do is get the general idea down, to get something that you could apply to other situations. So you don't have to memorize Cyprinodon nevadensis if you don't want to. What I do expect you to get from this is a sense of how speciation works. Speciation just means the formation of new species. There are several ways it can happen. This takes me about a week or a week and a half to cover in my upper division classes. What you get in the kind of Cliff's Notes version of biology, that's all I have time for, is a look at a way that speciation happens, a mode of speciation called allopatric speciation. For those of you keeping score at home, patric is the same as Latin patria, meaning your fatherland. So patric means your homeland or your fatherland, right? If you love your patria, you are patriotic. And allo is Greek for different. So allopatric speciation is speciation in different homelands. How does it work? We start with a population of an existing species. That's a group of individuals that all potentially interbreed and are all genetically related to each other in some way. Okay, it could be all of the birds on, all of the birds of one species on one island that are all potentially able to mate with each other. I mean, the male birds aren't mating with other male birds and leaving offspring, of course. But the males, all of the males in the population have the potential to mate with all of the females in the population. It could be all of the plants of a particular species on an island. It could be all of the prairie blazing star wildflowers in the UCA Nature Reserve in June. Whatever it is. It's a group of individuals that can all potentially interbreed. And then that population is divided. Two ways that could happen. One is the population just stays where it is, but a barrier comes up and splits the population. It could be an earthquake cracking the ground. That's actually not real common, but something like that could happen. It could be a river changing its course. It could be climate change, putting a desert area in between two mountains that used to not have it. It could be, this is more than we're going to have time for, but it could have something to do with what we call plate tectonics, the very slow movement of continents. It could be the building of a road. There's lots of things that could split that population. The other possibility is that some of the individuals from your founding population end up migrating across a barrier that they don't usually cross and form a new population. This is probably what's happened in the Galapagos Islands, where you have species from the South American mainland that don't normally cross open water. But a few of them made it to the Galapagos Islands and settled there and founded a new population. Maybe some seeds got washed out to sea and carried by the currents. Maybe some birds got blown to the Galapagos by a storm and were able to settle there and have babies there. Whatever it might have been. Whatever happens, whether individuals migrate or a barrier appears, the starting population gets divided in two. Now that you have two separate populations, the two start to become different from each other because of natural selection, plus a couple other things that we can't yet get into. Maybe I'll be able to pick this up a little bit later. Given time, each population kind of goes its own way. And if the populations become so different that they can't interbreed, we have to call them new species. How do we know that this has happened? This is why I want to give you the case study, to give you a sense of how we do know, or at least infer, that this sort of thing can happen. How do we put the pieces together? This is where I used to spend an awful lot of time. That's a pretty typical view in the Mojave Desert, which is pretty much southeastern California and the southern half of Nevada. That was taken in a place called the Alexander Hills, looking over China Ranch Valley to the Nopah Range out in the distance. This is not close to anything in particular that you're likely to have heard of. Although we're not too far from the south end of Death Valley National Park, which is a fascinating place that you all should visit if you can. If we had the money, I swear I'd put all of you folks on air-conditioned buses and take you on a 2-week tour, and then you'd really learn some stuff. What I want you to see is that right now there is not a great deal of water because, duh, it's a desert. Okay, the definition of a desert is less than 10 inches of rainfall a year. That's less than 25 centimeters a year for those of you that prefer metric. It is very dry. But if you start looking carefully at that desert terrain, you start finding things. Over there on the lower left, that's a picture taken in a range of hills on the other side of Death Valley National Park in a place called the Owens Valley. You have kind of dark rocks, and cut into the rocks, you have the channel of an ancient river. The only problem is that that river doesn't exist anymore. It doesn't flow, there's no water in it, but something had to have eroded that channel. There used to be a river there, although there isn't now. Over on the right, one of the cooler places you could hike is Mosaic Canyon in Death Valley National Park. And it's cool because a stream has eroded a very narrow canyon through layers of marble, this very hard rock that takes a high polish. So you're climbing through this canyon made out of polished marble. It's like you're climbing through the world's largest and funkiest bathroom. It's a really cool place to see. And what you're looking at right there is a little chute carved by a waterfall. The problem is that there's no water there because Mosaic Canyon's in the middle of the bleeping desert. But evidently there used to be a lot more waterfall, because you can see these structures that look exactly like they were carved by flowing water. So you can map stream channels, you can map the beds of lakes that dried up many years ago. You can even find ancient beaches. And that's one. That's in Death Valley National Park along a little road called the Beatty Cutoff Road, going from the park to the little town of Beatty, Nevada. You can see the bed of the road itself, but on the other side, you can see the road was cut through a ridge, a very long and very low hill. The ridge is made up of pebbles. The pebbles are actually rounded, and you get rounded pebbles. What rounds them is being tumbled by the action of water. What you're basically looking at here is a trench that's been cut through a pebble beach, much like what you could find in Arkansas on places I've been on the Buffalo River, have similar beaches on the river that are made of, rounded lumps of rock. I've explored similar ones on the shore of Lake Superior in northern Minnesota. There's other places in the world you might encounter pebbly beaches like this. And what you're looking at is an ancient beach. You can trace the ridges like this from miles all around Death Valley. Death Valley now is famous for not having any flippin' water in it. There's a reason why it's called Death Valley. Very dry almost all of the time. They do get a little bit of rain in winter, but it's not very much. But here you've got this beach surrounding the valley, and that shows you that the valley used to be filled up with water. And in fact, there was a pretty good sized lake in it about 10,000 odd years ago, at about the time that the first Native Americans were coming into the area. I said Native Americans. We can even find places where people built fish ponds on the shores of lakes that have not had any water in them for centuries. This didn't happen that long ago. There were fully modern people running around, probably the ancestors of some of the native tribes that live in the area to this day. So if we put all of these lines of evidence together, these old riverbeds and these dried lake sediments, even a few fossils we can find, like footprints of animals walking through mud that is hardened into rock thousands of years ago, even a few fossil fish. Put all of that together, and we can map a whole network of rivers and lakes. It would have looked like this. That dashed line on the map that you see is the present-day California-Nevada border area. The city of Las Vegas is down kind of in the lower right. I'm not sure if you can see my arrow, but Las Vegas is down there. Los Angeles would be probably off the map, but over to the left-hand side. And there is, with very few exceptions, there's no water in that desert area now, but this is what it would have looked like. There was an entire river called the Amargosa River, and that system connecting several lakes and several tributaries, flowing through what is now very harsh desert because the climate was cooler and it was moister about 10,000 odd years ago. I'll have more to say about this at the very end of the course. but climate does change. It's what it does. Um, it is true that humans have been affecting the process in ways that are not likely to be very pleasant for us. But even if humanity did not exist, the Earth's climate goes through changes. It's just what it does. And 10,000 years ago, the climate in the desert used to be cool enough and wet enough that it could support this network of rivers and lakes. What's happened is that as that part of the world has warmed up and dried up, well, the rivers have dried up, the lakes have dried up, and all that's left is a few little pockets of areas where water coming from springs, water coming from underground, has kept tiny little parcels of desert land wet. And it's these little isolated pools that preserve all that's left of the life that must have once filled all of those lakes and rivers. There were fish, there were plants, there was a pretty lush ecosystem set of plants and animals living in all those rivers and lakes, as there would be in rivers and lakes anywhere. And this is one of the few little pockets of it that's left. This is Crystal Spring. It's at a location called Ash Meadows National Wildlife Refuge in the state of Nevada, outside the town of Pahrump, which rhymes with dump, crystal meth capital of the state. But if you were to ever go to Las Vegas and get tired of the buffets and the slot machines and Celine Dion or Britney Spears or whoever it is that's singing there these days, you could rent yourself a car, drive over the Spring Mountains on State Highway 164 to the town of Pahrump, which rhymes with dump, drive a little north of town, and then take the Ash Meadows Road. And in about 30 minutes, you could be seeing this. The Ash Meadows National Wildlife Refuge preserves some springs that is all that's left of what used to be the life that filled all of those lakes and rivers. And if you walk up to the edge of Crystal Spring and you look down, it's very shallow and it's very clear, and you see fish. And you see fish that look like this. This is Cyprinodon nevadensis, the Amargosa pupfish. And they're really fun to watch. The females are kind of brownish in color. The males are iridescent blue. You don't really get that in this picture, but the males are quite blue and shiny. They swim over these rocks, feeding on the algae that grows on the rocks. And watching them is like being in the middle of, a very crowded, very popular bar where all of the guys are hitting on all of the females. Because the males are constantly swimming up to the females and constantly chasing each other away from choice females. So every male is constantly going, hey, 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 baby, hey, baby, hey, can I get your number? Hey, baby, hey, asshole, back off. Hey, baby, hey, where'd you go? Hey, baby. It's just, like the worst meat market you've ever been in. Anyway, so a lot of fun. I could watch them for hours. And this species is only found in Ash Meadows and a couple of springs that are outside the reserve. At the lower right, there's one of the places where you could find them. That is King Spring at Ash Meadows National Wildlife Refuge. And these fish are called Cyprinodon nevadensis. The common name is pupfish. If you were to drive out of Ash Meadows, maybe just a couple of miles, you come to a place and you can't actually get up close to it anymore. You can see that it's fenced off through a chain link fence. This is what it looks like. It's a water-filled crack in the ground. Okay, hang on. I see somebody's trying to enter. There we go. It's just a crack in the ground with water at the bottom. It's called Devil's Hole. Devil's Hole actually leads to some water-filled underground caves. The reason you can't go down there is that scuba divers went down in the 70s to explore these caves, and several of them died because diving in water-filled caves is extremely dangerous because you can't just bob to the surface if you're running out of oxygen in your tanks. All right, you run out of, you get lost in those caves, you're in real trouble if you can't find your way back to the surface. So you're not allowed to scuba dive in there anymore. But living only in Devil's Hole and no place else in the world is a second species of pupfish. You can't tell this from the picture, but it's about half size. It's missing a fin that most fish would have. And they did experiments on this back in the 50s. You can't breed it successfully with Cyprinodon nevadensis, the one I showed you earlier. So this fish and that fish cannot interbreed. There's some other more subtle physical differences between them, and we call this one Cyprinodon diabolus, the Devil's Hole pupfish. Okay, leave there and drive. It'll take you maybe an hour, hour and a half, and go into Death Valley National Park itself. One of the places you can visit is called Salt Creek. And at the lower right, you can see what Salt Creek looks like. There's a boardwalk where you can walk along Salt Creek. Now it's called Salt Creek because the water is, salty. It's about as salty as the ocean, whereas the other two places I've shown you, the water is very fresh. Only a few plants can tolerate growing close to salt water like that. One of them is called pickleweed because if you eat it, it tastes like pickles because it's so salty. And what lives in Salt Creek is Cyprinodon salinus, the Salt Creek pupfish. The differences aren't maybe terribly easy to see, but it is physically different from Diabolus and nevadensis. It lives in a very different environment, salt water as opposed to fresh, different sources of food available. And it's not found anywhere else but Salt Creek and a nearby little patch of salty wetlands known as Cotton Ball Marsh. And it's separated from the other two by something on the order of 100 miles. Okay, call it 160 kilometers for the metric contingent. Okay, then you could leave Death Valley, drive over a couple of mountain ranges. It would be maybe a 2-3 hour drive, and you end up in a charming little California mountain town called Bishop. Bishop's a really cool place if you want to do skiing or hiking or anything that involves having fun in the mountains. It's a great little place for hikers and backpackers. You could stop at the Bureau of Land Management office and get a map to a place a few miles out of Bishop called Fish Slough. So there's a close-up of Fish Slough. It's, another patch of wetlands. It's separated from the other three places that we've seen by a couple hundred miles, a couple hundred very dry miles, I might add. And it is home to a fourth species of pupfish called Cyprinodon radiosus. Radiosus used to be found all through Fish Slough, which is several miles long, until somebody introduced largemouth bass into Fish Slough, which promptly ate the pupfish like they were popcorn. They're now quite rare. A few years ago, someone a worker for the California Department of Game and Fish, actually saw that the last remaining pupfish were in danger of drying out. They were trapped in a puddle that was going to dry out. So he actually filled a couple of buckets with the fish and carried them to safety. You hear about conserving endangered species, but it's not very often that you can save an endangered species by carrying the entire species in a couple of damn buckets. And he got them to a place that was safe from predators and not about to dry out. So they were saved. It's a good story. Right. There's a map of where all of these locations are. So you can see where Vegas and LA are. The Amargosa pupfish and the Devil's Hole pupfish are both there down at the lower right. They're only separated by a couple of miles. Salt Creek is maybe 100 miles, okay, 160 kilometers away from Devil's Hole pupfish and Amargosa pupfish, and that's solid desert in between. There's no way a fish is going to be able to crawl 160 miles through harsh deserts and over mountain ranges. The Owens Valley pupfish is separated by even a greater distance. So each of these species is restricted to isolated pockets of water separated from each other by miles of desert. How did this happen? And we can expand this picture further, by the way, because in other parts of the desert, there are other pupfish species, probably about 20 in all, in the Southwest United States and also in northern Mexico. Almost every one of them is restricted to a few little springs or streams or other little refuges like that. Most of them are highly endangered. They don't have a very wide distribution anyway. It might just be a few little streams or ponds or something like that. And this being out in the desert, water is in high demand. So a lot of habitat that used to contain fish, the water's been diverted for people to use. But there's still about 20 of them left, all of them with the spotty distribution, found in only isolated spots, and all of them restricted to just tiny little wet pockets separated from each other by miles of desert and semi-desert. How'd this happen? Well, we think that pupfish got into the American West through the Colorado River. There are some pupfish that actually can live in the ocean. There's actually some that I've seen in Florida, for example, on the Gulf Coast. And from the ocean, we think they spread up ancient river systems, and they got into that system I showed you earlier of connected lakes and rivers in the Mojave Desert. All of those blue squiggles and blobs on the map that I showed you a ways back. So by about 11,000 years ago, we had pupfish living in that system of lakes and rivers. They probably could migrate from one to the other, and they might have all been able to interbreed. Pupfish from anywhere in that system of lakes and rivers could have bred with pupfish from elsewhere in the system. But the climate starts getting warmer and drier about 10,000 years ago, give or take a couple of weeks. The rivers begin to shrink. The rivers start drying up. The rivers no longer connect the lakes, so pupfish in one lake can no longer swim to a different lake. They're trapped where they are. And then most of the lakes dry up, and what we're left with is isolated populations of what used to be the same species that now can't mingle anymore and can't, interbreed any longer because they're blocked, because there's no way to swim from what is now Salt Creek to what is now ash meadows or to what is now fish slough. So we have isolated populations. They no longer can interbreed, and each one is subject to different conditions. So one isolated population is stuck in a creek that's fed by salty spring water, and the water's getting increasingly salty. Some of the fish are in spring-fed ponds that are warm. I didn't mention this, but at Ash Meadows, water comes out of the rock at about, I think it's 92 degrees Fahrenheit, call it 35 Celsius, all year round. It would be a great place to take a bath if it wasn't also endangered species habitat. On the other hand, fish slough gets really cold. So these little pockets of water all have different temperatures, different amounts of salt, different types of food available, different predators. They all become different from each other, and natural selection will cause each of those isolated populations to change, to adapt to different conditions. In Salt Creek, the pupfish that can tolerate salt best will leave more babies than the ones that can't tolerate salt. At Fish Slough, the pupfish that could tolerate cold will do better and have more babies than the ones that can't. On and on and on, given enough time, only a few thousand years, in the length of time that humanity has lived in the desert, we have new species of pupfish. That's how allopatric speciation works. And I've gone into that detail, not because I want you to memorize that level of detail, but because I want you to see from a hands-on, well, we can't go hands-on now. It's about 2 days drive out there, but I want you to see as much as possible of the evidence, how we put together a case that this is what has happened. And incidentally, the same pattern can be observed in other desert fish. Those spring-fed ponds don't just have pupfish. They have another little species of fish called pool fish. They have little minnows in the genus Rhinichthyes, known as dace. They've got snails. Ash Meadows has 10 species of freshwater snail that are found nowhere else in the world but there. There are plants. There are wildflowers that are found only at Ash Meadows and nowhere else. You could basically just keep telling the same story over and over and over again, with not just with pupfish, but with many other species too. And there's many variations on this story, but what I hope this has done is give you some idea of how we can make a case that new species do form, how we can observe the process happening and reconstruct relationships through common ancestry of all of the species in the world, a concept that we know as the tree of life, which I'll talk more about on Wednesday. But today, it being time, I'm going to go ahead and stop recording as soon as I can find the stop recording button. There it is, and I will stop right there.